Good morning, everybody. Forgive me. So I'm going to start off with describing or adding a little bit more to the discussion in the previous video, and then I'm going to loop back into section 1.1 and 1.2 in the text. But I will point something out that I'm going to ask that you read through section 1.3 and read through section 1.4 and spend more time on that on your own. The material that we're going to discuss here are high points that, again, people have traditionally struggled with. And so if you have questions about anything in 1.3 and 1.4 that I haven't touched on in a video, you are welcome to ask. I can make a video, or during class time, either virtually when we're meeting on the Zoom call, or in class face-to-face, you can ask. So my first comment is that simple random sampling, when I was describing it yesterday, was done with replacement. There are times you do it without replacement. So if you have people and you're trying to select them from a study, you really can't select the same person twice to be in a group. So without replacement would be appropriate at that point in time. So simple random sampling can be done with or without replacement. You can generate natural bias if you're doing it with replacement, and that was motivation for some of the other types of sampling techniques that are used. A comment as well, voluntary response sampling just inherently has bias, and because the people who generally respond to those types of surveys have more interest in the topic than the rest of the population. All right, so just keep those things in mind. We're going to talk about statistic versus parameter. All right, so notice there's no S on the end of statistic. So if I said statistics with an S on the end, that would be the study of, and we are in the class statistics. A statistic is a numerical description of a sample characteristic. There it is. Now, a parameter is a numerical description of a population characteristic. All right, I don't know why that didn't hyphen out differently, but let's do that and see if that did it. Nope, it seems to be fighting me a bit. So that's fine, not a real big deal. So common ones that exist in both are the mean, the variance, and the standard. Let me put this in a different spot so I can show you what I mean. So there we go. So we have the mean. I keep putting mean mean, the variance, and the standard deviation. Okay, well, statistic is from a sample, and parameter is from a population. And I'm going to do something here. So if we are talking about, and I'll loop back down here, we're going to insert, where is it? There it is, equation. I'll cut it out. And you don't need to, I'm just going to try and show you the symbols. That's all I'm trying to get you to be able to see here. So we have the equation. It's fighting me a little bit. It's supposed to pop up. There we go. Just give me a sec. I don't know why it's doing that. I'm going to do it a different way. Um, there's typically a way to do it with typeset, and it seems to be fighting me. So I'm going to do it by drawing it in, and we can just sort of use that as a standard. So if I say the mean from a sample, let's do that in red so I can see it easier, or dark blue, black. There it goes. So the mean, if it's a sample, you'll see the notation as x bar. If it's a population, you'll see it as mu. So you can see it written differently for a statistic. This is the statistic or a parameter that is your mu. Now variance has S squared for sample variance, and then for population variance it's sigma squared, and then there's a connection between variance and standard deviation, and I'll describe that in a second, but standard deviation for sample is S, and standard deviation for population is sigma. Now, in any situation that we're working with, to get from variance to standard deviation, you take the square root. And so by applying the square root, the square drops off. Other symbols that you could have median. Now the median would be x, and instead of the bar, it'd have a tilde on top, or a mu with a tilde on top, and then you're talking about median. So these are the symbols for median, and that is the sample statistic, and that is the population parameter. And there are others, but I mean, hopefully you get the idea. Let me scroll down. We're going to talk about discrete versus continuous, and I'm going to go here, and I'm going to go back to that's what I'm looking for. So there, now I've got my ability to type again. Discrete versus continuous. So when we're dealing with statistics and we're dealing with continuous data, there is a dilemma that you always face, and that you always have to refine it at some point in time. And so you take continuous and you often make it discrete. But let me try and explain it a little bit differently than that. A discrete. So when you're looking at a staircase, so discrete, when you're looking at a staircase, and you're counting the number of stairs, that's a discrete case, because there's one stair, there's two stairs, there's three stairs, there's four stairs. You don't build 1.5 stair. You have one stair, two stair, three stair, that kind of thing. So we talk about that as discrete. Continuous is when we can keep refining it. So my weight, I weigh approximately 230 pounds. When I was born, I was 9 pounds 13 ounces. There wasn't a value that I skipped. I didn't go from 60 pounds to 70 pounds one day and miss all of those things, including the fractions and including the decimals. Continuous is I can refine it as much as I need to make it work. If I'm talking about grams or centimeters, I can keep refining those things often to infinity, and measure it to any point of accuracy that I need to. And so continuous allows us to do that. Now, let's just take some examples here. The age of a person at his or her last birthday. So the way we deal with age in our country is we describe it as I'm 56 years old until you become 57 years old. On the day that you celebrate your birthday, you are now 57 years old. Now you can argue certainly against that and say, well, there's 3 years old where they go, I'm 3.5, or I'm halfway there, kind of thing. but typically the way we describe it is in a discrete set. Um, Height is considered continuous. Uh, Again, you could measure me to the 10th place, the 10th decimal place, the 100th decimal place, the 1000th decimal place. You could measure me in centimeters, you could measure me in feet, and so forth. But you're not restricted to just, I'm 6 feet. You could say, well, there's 6 feet, 1 inch in point, micro inches kind of thing. The number of siblings a person has. Definitely, this is a discrete situation. It's a count. Um, so, distance a person commutes to work. It's generally continuous. Um, all right. Now, we have some descriptions of things that I need to sort of blather about, and I apologize for this. So, we have some ways of describing data, and they are categorical and they're numerical. Sometimes categorical gets described as qualitative, and numerical is quantitative, and they're fairly interchangeable. The thing that you need to recognize is that we do different procedures based on whether we have categorical or if we have numerical data. And it's often the case that when we're dealing with categorical data, we also get numbers. So that causes some confusion. And so what I'm going to talk about here is the typical thing that we deal with when we have categorical data or qualitative data is we talk about proportions. So if the category that we're looking at is red car, and we're sitting at a corner, the proportion of cars that drive by that are red, 3 out of 10. So we end up dealing with values as in out of. And the question that often gets asked to be able to differentiate between, is it really categorical? I mean, some stuff is obvious, like if you're just talking about, how many red cars and they're all red, 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 or you're talking about names, those are definitely categorical. But proportions are still categorical data. So if I have 3 out of 10, if I have 7 out of 40, those are definite ratios. But the question that we could ask is it easily made into an average? Can I make a mean out of this? And if you can't make a mean out of the data, then it's most likely we're talking about a categorical or a qualitative situation. Numerical or quantitative, you take my height, you take your height, you take everybody's height in the class. Could you make an average out of that? Could you add up all the heights and divide by how many people there are in the class? And the answer in that case is yes. And so that information would be numerical or, numerical, or it would be quantitative. Now, we could talk about the number of individuals in our class that identify as male. And then that is a categorical set of data, and we would be looking at it as a proportion. We would be looking at the numerator as the count of individuals that identify as male, and then the total number of individuals in the denominator. And you can change that statement to whatever you want to. So it could have been the number of individuals that identify as female, the number of individuals that identify as non-binary, and there are other categories. So whatever those categories are that you want to focus on, you can look at those categories and you can have that in the numerator, how many are in the numerator out of the total, and that's the denominator. So categorical, and I didn't put any of those up into this space, but I will now. And I got to go back to drawing just a second. So I'm going to click here. So try and get the dot back. There we go. So what happens is when we're dealing with categorical, we're often talking about proportions. And so the sample proportion or the sample statistic is P with this hat on top. It's pronounced P hat. And then you have this capital P as the population proportion. Now there will be some other goofball things that pop in here when you're dealing with proportions, and we'll have to discuss them as we go. But we will end up with a thing like P bar and some other relationships that we have to flush out as we go, but nothing that we need to be concerned with right now. All right, let me go back to getting my typeset. There we go. And we were talking about categorical and qualitative and so forth. All right, so from here we get a, oh, did I lose it? Oh, there they are. There's the typing. That's what I was looking for. So we have a thing called levels of measurement. And levels of measurement fall in one of four categories: nominal, ordinal, interval, or ratio. Nominal is in name only. Ordinal is data that is potentially ordered. And so I'm going to do this little split here, like so. Generally, nominal and ordinal fall in categorical, but there are times that ordinal can land over with interval and ratio. So it depends on how you use your data, depends on where ordinal is landing. So nominal is described as in name only. So, red, lists of colors, color of eyes, color of shirt, and you're just counting the color, or not even counting the color, you're just listing the colors. Now, ordinal, you can generate a rank. There's a natural occurrence of a rank. So if you look at people's favorite TV shows, people's favorite YouTube channels, and you take a count as to which one people prefer, well, you're getting a count then, and it's still considered categorical, but sometimes if you have to look at the counts, you might be able to do something that is numerical with it. And so the ordering does generate, or the ranking that can occur does generate the possibility of some numerical responses. It's rare, just be aware that it does happen at times. Okay, so generally, nominal and ordinal are considered categorical, okay, and interval and ratio are considered quantitative or numerical. And so I have this sort of split here. Let's talk about interval. Interval, and I'm going to put this not mathematical zero, as well as doubling, does not really apply. Okay, so one of the best examples of interval is, and I don't know what I just did. Oh, I just lost a page there. That's fine. So the best example of interval is temperature. And what I mean by that is and I don't know what I just did. There we go. Sorry. So one of the best examples of interval, again, is temperature. And the reason is zero, the temperature zero is a temperature. It is not the absence of temperature. And so that's what I mean by as not mathematical zero. Mathematical zero is the absence of a value. So if you look in my wallet, I don't have any money in my wallet. I have $0. That is the absence of. And so what happens is money is a good example of ratio. Now, I will touch on something in a second, and I'm going to put a little note here so I don't forget to say it. So doubling does not really apply. So let's talk about temperature again. And in temperature, if I'm if it's 1 degree today, I'm going to dress a certain way, and if it's 2 degrees tomorrow, I'm going to dress probably the same way, although the temperature did double, but the behavior didn't change. Now, if I look at 50 degrees to 100 degrees, 50 degrees, I'm outside in a sweatshirt and like a khaki short kind of thing, um, because I tend to run warm. But 100 degrees, I'm in a tank top, I've got slides on, and I've got sports shorts on, and I'm praying to find a pool. And so the behavior does change. And so doubling doesn't really match in interval. But ratio, if I have $10 today and $20 tomorrow, and I've doubled my amount of money, I can buy twice as much of whatever it is that I want to purchase. Um, or I'm that much closer to whatever big purchase I want to buy. My comment is I chew a lot of Trident cinnamon gum, so if I have $10 today and tomorrow I have $20, I'm able to buy twice as many packs of gum, um, and going from 10 to 20. And again, the zero thing applies. So ratio does have mathematical zero. And doubling does apply. And so there's some other ways to state this. So if I travel back, nominal does not have any mathematical operations that can apply. You can't add, you can't subtract, you can't divide, you can't multiply. Ordinal, you can rank. So ordinal has rank applied to it. Adding and subtracting doesn't really make any sense. Interval, two of the four operations apply. So addition and subtraction apply. Now, ratio, all four apply. You have addition, you have subtraction, you have subtraction. You have multiplication, and you have division. And all four will work. All right. And then my comment about negative numbers. I don't remember what textbook I had for this, but it said you can't get negative numbers in ratio, and that's completely not correct. So if I'm talking about money, I can owe somebody money, and so I can have a negative amount of wealth. And so you have to be careful about how some people will interpret ratio. If they're saying you can't have negative on a ratio, they are incorrect. You can. There are certain situations where it doesn't make sense to talk about the data set that you're working with, but ratio data can have negative values. Just putting that out there. I will make a comment that that began from somebody that was using a Chegg site, and the individual that wrote that at the Chegg place was very wrong. Moving on. Which of the following is a statistic and which is a parameter? So we're just going to hop back to that for a second. 57% of the teachers at Central High School are female. Well, the argument is it's because it's a parameter, or it's a parameter because they're talking about a segment of the entire population of teachers at the school. So the population is all of the teachers at the Central High School. And so defining your population, then that becomes a parameter. In a sample of 100 surgery patients who were given a new pain reliever. Okay, so we aren't dealing with all of the surgery patients. We're taking 100 of them. And so this 78% is a statistic. Okay. All right, so moving on a little bit. Control group and experiment group or treatment group. So control group, when we're looking at experiments versus observational studies. So an experiment versus an observational study. So very quickly for the moment, an experimental study is a study where you're controlling the variables. There are some other descriptions out there, and they're effective descriptions. So an observational study is a study where the person that is performing the study does not have control as to whether the individual that they're dealing with is placed into the control group or into the treatment group. And that's a fairly common description. Basically, what's happening is an experiment you have control over the variables, and an observational study you don't. And so we need to be able to describe this a little bit further. So there's a thing typically in an experiment called a control group, and sometimes there's another group called the experiment group or the treatment group. And it's two names for the same thing. But basically what's going on is this is the group that gets the medicine, and this is the group that gets the placebo, the fake drug. Okay, so our placebo is a fake drug. So they get a tablet or a sugar tablet that looks like medicine. Well, there are some problems with this, but let me talk about the motivation behind this. So statistically, we would like to have and compare two groups. And when we're dealing with the two groups, we have to try and set one group up to not get a treatment to see what the body naturally will do, for instance. And then we take another group and give them the medicine to see if that medicine has what is referred to as a statistically different response. And we compare those responses. And if there's not much of a difference, we say, well, the medicine didn't do anything. The body was fine. The control group performed as well as or almost as well as the experiment group or the treatment group. But sometimes we have this occurrence where the medicine makes a radical difference, so it's statistically different. And then we say, oh, look, we have something here. The control group only got to this mark, I'm just speaking ethereally, and then the treatment group got way, way better. And so it's clear that the medicine supported the body in whatever process that we're looking at. Okay, now there is a problem, and the problem is that humans tend to communicate a great deal through their body language. And so the person distributing the drug or the placebo often will have tells and will indicate to the person receiving the drug or the placebo which they're getting. And so the purpose of a blind study is so the individual who is handing out the drugs does not know whether it's a drug or a sugar pill, and then they cannot communicate to the individual which they're getting. The next thing is double blind. So the person giving the person who gives the drugs often... Oh, I screwed that up. I just described double blind. Let me go back. My apologies. So blind, the person receiving the drug or the placebo doesn't know. I just did double blind. And most of the time you are in a blind study. But the human person often that's distributing the drug or the placebo will have a tell. And so they also make it so the person that's distributing the drug doesn't know. And we're not going to create any sort of bias in the study. So let me reiterate, and again, my apologies. So blind, the person receiving the drug doesn't know if they're getting the drug or the placebo. And that way, we're trying to make sure that the mind isn't impacting the body. The body's just doing what it's doing. And then double blind is the person that is distributing the drug and the person receiving the drug or placebo doesn't know. And so the person distributing the drug doesn't give a tell and a sign so that they pick up whether they had the the drug or the placebo. All right, now that I messed that up, my apologies again. So hopefully, experiment, variables are controlled, observational, just looking at. Now, let me scroll down farther. Which of the following variables are qualitative and which are quantitative? All right, so I know I'm bouncing around a little bit here. This little piece here, I just wanted to make sure that we get the difference between qualitative and quantitative. A person's age. It's a numerical value, so it's typically a pretty good indication that it's quantitative. I will make a comment. So age is quantitative. But what if it was a number on the back of a jersey? So the number 2 or the number 22 or the number 14, and it's just on the jersey. Well, you can't really add numbers on a jersey, so it's more qualitative at that point. Poise? Wow, that's weird. All right. A person's place of birth. That's qualitative. The mileage of a car in miles per gallon. So you're talking about quantitative. And then finally, the color of the car. That's qualitative. All right, again, my apologies for my little mix up here with the blind and the double blind. Hopefully you have it straight. If not, make sure you ask. Okay, that pretty much concludes chapter 1, and I will talk to you all later.